4 centuries ago, a Dutch spectacle maker pointed a simple tube at the night sky. Today we can see baby galaxies, white black holes, and even imagine black holes as shadow. This is the story of the telescope, how it began, how it changed everything, and what's next. The invention. Our story starts in 1608 with Hans Lippershey, a Dutch spectacle maker who applied for a patent on a device for seeing far. A year later, Galileo Galilei, Italian astronomer, physicist and engineer, built his own and aimed it at the heavens, discovering the 4 largest moons of Jupiter, the phases of Venus, mountains on the moon, and more, publishing in Sidereus Nuncius in 1610. In 1611, Johannes Kepler, a German astronomer, mathematician, astrologer, natural philosopher, and writer in music, described the Keplerian design with 2 convex lenses, giving wider fields and higher magnification. Reflection revolution. Refractors suffered from color fringing. In 1668, Sir Isaac Newton, English mathematician, physicist, astronomer, alchemist, theologian, and author, built the first practical reflecting telescope, using a mirror to focus light and eliminate chromatic aberration. This Newtonian reflector set the stage for big mirror astronomy. Giant telescopes from the 18th and 19th century. In the late 700s, Sir William Herschel, a German-British astronomer and composer with the help from his sister Caroline Herschel, pushed telescope making to extremes. William's 40-foot reflector, completed in 1789, was for a time the largest in the world. He famously discovered Uranus in 1781 using a smaller instrument and mapped thousands of nebulae. In 1845, William Parsons was an English engineer and astronomer. The 3rd Earl of Rose, better known as Lord Rose, built the 72-inch Leviathan of Parsonstown. With it, he sketched spiral nebula, foreshadowing the idea of galaxies beyond the Milky Way. The age of precision refractors and Mount Wilson. The 19th century also saw superb refractors. The 40-inch Yerkes refractor in 1897 remains the largest refracting telescope ever built. In the early 20th century, George Ellery Hale, American astrophysicist, best known for his discovery of magnetic fields in sunspots, and as a leader or key figure in the planning or construction of several world-leading telescopes, spearheaded a sequence of record-setting reflectors, the 60-inch and 100-inch at Mount Wilson, and later the 200-inch Hale telescope at Palomar, first light in 1948, with the 100-inch Hooker telescope. Edwin Powell Hubble was an American astronomer. He played a crucial role in establishing the fields of extragalactic astronomy and observational cosmology, measured galaxy distances and redshifts, revealing an expanding universe. Radio astronomy is born. In the 1930s, Carl Gus Jansky, who was an American physicist and radio engineer, who in April 1933 first announced his discovery of radio waves emanating from the Milky Way. At Bell Labs, detected radio waves from the Milky Way, effectively founding radio astronomy. Soon after, Groot Reber, an amateur radio engineer, built the first purpose-built parabolic radio telescope in his Wheaton, Illinois backyard. In 1937 and 38, these pioneers opened a new window on the cosmos. Big arrays, Arecibo, VLA, and interferometry. By the late 20th century, radio telescope grew into giants and networks. Puerto Rico's Arecibo Observatory, 305 meters in 1963, made the landmark discoveries before its tragic collapse in 2020. The Carl G. Jansky Very Large Array VLA in New Mexico links 27 dishes across 36 kilometers, using interferometry to act like a single huge telescope, delivering exquisitely sharp radio images. Adaptive optics sharpening Earth-based vision. Even with the huge mirrors, Earth's atmosphere blur images. In 1953, Horace Wilhelm Babcock purposed adaptive optics, rapidly reshaping a mirror to cancel atmospheric turbulence. with modern computing and lasers. AO, or adaptive optics, now lets ground telescopes rival or even exceed space telescopes in resolution. Modern optical giants. Modern observatories combine large, lightweight mirrors with adaptive optics and clever engineering. The WMKIC Observatory on Mauna Kea pioneered 10-meter segmented mirrors in the 1990s. In Chile, the ESO Very Large Telescope (VLT) operates four 8.2-meter telescopes that can also work together interferometrically. Space telescopes, Hubble and Webb. In 1990, NASA and the European Space Agency launched the Hubble Space Telescope. The Hubble Space Telescope (HST) or Hubble is a space telescope that was launched into low Earth orbit in 1990 and remains in operation. It was not the first space telescope, but it's one of the largest and most versatile, renowned as a vital research tool and as a public relations boon for astronomy. The Hubble Space Telescope is named after astronomer Edwin Hubble and is one of NASA's great observatories. The Space Telescope Science Institute selects Hubble's targets and processes the resulting data, while the Goddard Space Flight Center (GSFC) controls the spacecraft. After a 1993 surfacing mission fixed its optics, Hubble transformed astronomy with ultra-deep images and precise measurements. In 2021, the James Webb Space Telescope (JWST) is a space telescope designed to conduct infrared astronomy as the largest telescope in space. It's equipped with high-resolution and high-sensitivity instruments, allowing it to view objects too old, distant, or faint for the Hubble Space Telescope. This enables investigations across many fields of astronomy and cosmology, such as observation of the first stars and the formation of the first galaxies, and detailed atmospheric characterization of potentially habitable exoplanets. Although the Webb's mirror diameter is 2.7 times larger than that of the Hubble Space Telescope, it only produces images of comparable resolution because it observes in the infrared spectrum of longer wavelengths than the Hubble's visible spectrum. The longer the wavelengths, the telescope is designed to observe, the larger the information gathering surface. Mirrors in the infrared spectrum or antenna area in the millimeter and radio ranges required for the same resolution. Launched in 2022, its first images revealed infinite galaxies, stellar neuroseries, and exoplanet atmospheres. Imagine black holes' shadow. In 2019, the Event Horizon Telescope (EHT) is a telescope array consisting of a global network of radio telescopes. The EHT project combines data from several very long baseline interferometry (VLBI) stations around Earth, which form a combined array with an angular resolution sufficient to observe objects the size of a supermassive black hole's event horizon. The project's observational targets include the two black holes with the largest angular diameter as observed from Earth, the black holes at the center of the supergiant elliptical galaxies Messier 87 and Sagittarius A at the center of the Milky Way. EHT, a global network of radio dishes, produced the first image of a black hole's shadow in galaxy M87 in 2022. EHT reveals the shadow of Sagittarius A, a supermassive black hole at the center of the Milky Way, interferometry perfected. What's next? Mid-2020s to early 2030s. The next decade will be a golden era. In Chile, ESO's extremely large telescope ELT, a 39-meter segmented giant, targets first light around 2028. The Vera C. Rubin Observatory will begin wide-field sky surveys, repeatedly imagining the entire visible sky to catch transients. NASA's Nancy Grace Roman Space Telescope aims to launch in 2027, hunting exoplanets and dark energy signatures. And in radio, the Super Kilometer Array (SKA) will link thousands of antennas across countries to probe the early universe and cosmic magnetism. Why telescopes matter. from Hans Lippershey and Galileo Galilei to Horace W. Babcock and the Event Horizon Telescope. Every step in telescope design expanded our senses. The next steps from ELT, Rubin, Roman, and SKA promise discoveries we can't yet imagine. Thank you for watching. See you next time.